Welcome to part 2 of special lines in a triangle. This is the third line, which is height. A height is a segment issued from the vertex perpendicular to the opposite side. Perpendicular meaning making angle 90 degrees. Now, how to draw the height of a triangle? We have three cases. Case 1, if the triangle is a acute triangle. First, we choose a vertex, for example, A. If we choose the vertex A, now we place the set square on the opposite side, which is BC, making angle 90 degrees, and now we draw a line from A to BC. And this line is called the height. In any triangle, we can draw three heights. So this is the first height, AM. The second one, we put the set square on AB, making angle 90 degrees, and from C, we draw a line to AB, and CN is the second height issued from C to the opposite side, AB. The third height must be issued from B to AC. So we put the set square making 90 degrees with AC, and from B we draw a line to AC. And this is the third height, BK. Now, what did you notice, Leon? The three heights intersect at one point. Now, case 2, in right triangle, for example, ABC, right at C, we already have BC perpendicular to CA. So, BC is a height and CA is another height. Okay, how to draw the third height? Third height from the right angle to the hypotenuse. This is the right angle, the hypotenuse is opposite to the right angle. So, first we identify the right angle in this example C, then identify the hypotenuse which is opposite to C, which is BA. Now place your set square on BA making angle 90 degrees, and from C draw a line perpendicular to BA. Let me ask Maria. Here in right triangle, the heights will intersect where? Excellent. Not inside the triangle, on the triangle, and at the vertex making 90 degrees. Now case 3, in an obtuse triangle, let me ask Rami Darwish. What do you think? Where the height will be outside the triangle or inside the triangle? Excellent. So sometimes the height, as you can see in the figure, is outside the triangle. So in order to draw the height in this case, first we extend the opposite side of the obtuse angle, then we put the set square on the extended side, and from the vertex we draw a line making 90 degrees to that extension. So the height falls outside the triangle. The orthocenter is the point where all the three heights intersect in a triangle. And I will ask Mustafa, do we need all the three heights to find the orthocenter? Exactly. You do not need to draw all three altitudes or heights to find the orthocenter. Draw only two heights. Their intersection is the orthocenter. This is the orthocenter, the intersection of the three heights. Sometimes the orthocenter is not inside the triangle. It depends on the nature or type of the triangle. If the triangle is acute, the orthocenter is inside the triangle. If the triangle is right, the orthocenter is on the triangle. And if the triangle is obtuse, the orthocenter is outside the triangle. Let's take this acute triangle. Look, the orthocenter, the point of intersection of all heights, is inside the triangle. But in this right triangle, the orthocenter is on the vertex, or on the right angle, exactly on the right angle. And in an obtuse triangle, the orthocenter will be outside the triangle.
Now the last special line, which is perpendicular bisector. Perpendicular meaning making angle 90 degrees, and bisector, as we said before, cutting something into two equal parts. So it's perpendicular to a segment at its midpoint. So it must be perpendicular to this segment, not at any point. It must pass through its midpoint. Let me ask Noor Abu Zaid, how many perpendicular bisectors can I draw in a triangle? Excellent. So I can draw 3 perpendicular bisectors in any triangle. So, how to construct the perpendicular bisector? Noor Kibrit, do you have any idea? What do we use in order to draw the perpendicular bisector? We use the compass. Let's see this example. We have triangle ABC. First, if we want to draw the perpendicular bisector of BC, we use the compass. I put the compass on vertex B. I open the compass more than half BC. I draw the first arc. Now I move the compass. I keep at same opening to vertex C. I draw the second arc like this. As you can see, the two arcs meet or intersect at 2 points. Now using the ruler, I draw a line passing through the 2 points of intersection. And this line is the perpendicular bisector of BC. Let me ask Hannah, what is the properties of this line? Exactly, this line is perpendicular to BC and at the same time it's passing through its midpoint. Now let's draw the perpendicular bisector of the second side, which is BA. The same way, using the compass, I put the compass on B. I open it more than half BA. Now I draw the first arc. I draw the first arc like this. Keep the same opening. I put it on A and draw the second arc. The two arcs meet or intersect at 2 points. Using the ruler, I connect the 2 points to form the perpendicular bisector of AB. Yes, it's perpendicular to AB and at the same time it's passing through its midpoint. Now I will draw the perpendicular bisector of AC. Put the compass on C. Open it more than half AC. Draw the first arc. Keep the same opening. Put it on A. And draw the second arc. Like this. Now the two arcs intersect. Using a ruler, we draw a line passing through the 2 points of intersection, and this is the perpendicular bisector of AC. Look, Omar. What happened? The 3 perpendicular bisectors intersect at one point. This point is called the circumcenter. So this point, circumcenter. So what is the circumcenter? Is the meeting point of the perpendicular bisectors of all perpendicular bisectors. Okay? So let me ask Layan. Is the circumcenter inside the triangle or outside the triangle? Excellent. So the circumcenter is inside the triangle. And we don't need to draw all 3 perpendicular bisectors to find the circumcenter. It's enough to draw 2 perpendicular bisectors and the intersection of them is called the circumcenter. From this circumcenter, from the point of intersection of the perpendicular bisectors, we can put the compass and draw a circle passing through all the vertices of the triangle A, B, through C